So we've been dealing with all types of functions. Hey, we've been dealing with all types of functions and mostly been looking at the polynomial ones. Now we're dealing with greatest integer functions. Okay, here's the form. Brooklyn, can you just pay attention up here while I teach you guys what this actually is? Because you need to know this before you need to know that. There's a progression to this, so just follow along. Here's the scenario with these guys. They're considered step functions. And there's something you should add to your memory aid to kind of make this make sense, because there's 4 different ways you can kind of encounter it. Now, in terms of the actual rule itself, here's what's nice, right? Is that, oh, forgot to add in my little, here's what is nice, is that this is the only form in which you will see this guy. Okay, the basic version of this guy, right, is just going to be that. But that's with A being 1, B being 1, H being 0, K being 0. That is like the base format of it. What I want you to notice is the actual bars here that create this sort of different function. Okay, and you guys are also really lucky. This is the first time this is on the exam again in 3 years, so I haven't had to do this in 3 years. Yay, extra stuff. It's actually good because it kind of leads you more, preps you better for grade 11. Here's the only thing that's new is that B value right there. Okay? So we no longer just have like A, H, K to worry about. We've got this B guy here. And as always, you'll see next year as well, B always has its own fascinating little rules involved in it. Okay? But what does it actually look like in practice? Essentially, the best way I can describe it before I draw it on here is its pricing structure, right? Think about it, a car rental that you would have. So I drive it off the lot, I pay a certain amount, and if I had it for several hours, right? As soon as I have it, let's just say for 3 extra hours, I end up going up to a next pricing level. And then another 3 hours, I go up a next pricing level. So this version here is going to be when A is positive and B is positive. We don't care about the values just yet. And I want you to draw this on the front of that guy there. Put the formula on there as well. I don't want to just leave it on there because then it just becomes wallpaper. I want you to add it on yourself. But you kind of manually have to go in. If you have a diagram, it's not going to spit out that this guy is going to be A is positive and B is positive when we solve using algebra. It's just not going to do that. It's from the diagram, I'm going to have to know, right, that this guy's, that A is positive and that B is positive right there. Now, alternately, right, what if it went and stepped down? So we went this way. Okay. Then this guy here is going to be A is negative and your B is positive. Okay? Because I want you to think about it in this way. You can add these little arrows in if you want. We always start at where the circle is filled in. Okay? How many vertex are in a parabola? How many vertexes or vertices? There's one, right? Well, there's the H and the K that makes up a vertice, right? If you chose that as the vertex, Emma chose that as the vertex, Cole chose that as the vertex, and you guys wrote it out, you'd all be right. You can just choose to pick where you start. Okay? There's another reason why I like this for the sign. This leads so well into like sine functions and stuff that it's wild. But so I can choose anywhere I want. Now, if I'm starting at vertexes, then this would mean, in terms of stairs, like B is positive and A is positive. That's kind of the nature of what's happening here, right? Starting from here, going to the right is always considered positive, going up is always considered positive. Whereas over here, my B is positive in this case, right? But my A would be negative. So reason why I show you this is you can either reason your way through why A is positive and B is positive. If you have a logical brain, that makes sense. However, if you want to just be able to look at a diagram where it's like open, closed, or sorry, closed, open, and it goes up, just go to your memory aid and it's going to tell you. So you don't have to think about it. Yeah.
When is B going to be negative?
So B is going to be negative. We're going to go down here and use the same color here. So let's start on this guy here, where it's closed and then open. So I went in the opposite direction, and then I'm stepping down. So it's weird because we like to read functions from left to right, so it looks like it's a positive one.
Right.
But let me ask you this. I do it like this. This guy is A is negative, B is negative because the B is negative in that direction and the A is negative. What is a negative times a negative? If not a positive. Hence why this guy looks like it's still going upwards in a positive trend, because our like slope is defined by both A and B in a sense. Yeah.
Is B and A kind of like your X and Y all the time? Like
it's not your X and Y. It's essentially you're kind of on the right track. It's think about like the A value in a parabola dictating like how fat and skinny it is, right? A is going to dictate basically the height of the step, and B is going to dictate the length of the step. It's not the B is not an exact translation into the actual formula, but it essentially just kind of defines like the step lengths of it.
How wide your steps are.
Yeah. So the last part of this guy here would be which way am I going now? I think, open. I'm going to go open to closed. Actually, which way am I going here now?
Yeah, you're right.
Yeah, because I'm going to go on this guy here. We're going to have
you're gonna mirror the
A is positive and B is negative. So, right. And then on this guy, dang it, I'm starting in the wrong spot.
Yeah.
There we go. You got to start down lower. Okay. So again, if I do this at like 30,000 feet, these are the only things that you really need to know. That's the form the rule takes. These are the different ways that it can look. When it comes down to you being provided examples that look like this guy or this guy here, you'll have to manually put in that B is negative when I go create the rule. And we'll look at a bunch of examples that'll kind of explain this a little bit better. But that's it in a nutshell. And then there's specific rules about greatest integer functions in terms of how do they work. So there's special brackets, and there's two ways we interact with them. The first one is if I just have numbers inside the brackets, this is how I'm going to execute the brackets. And that's the phrasing I use for this guy. If I want to execute the brackets in terms of get rid of it, because that's not like a final answer. Those brackets just don't belong there, okay? So on something that looks like this guy right here, the greatest integer function value of 3 is just 3. Those bars essentially just mean no matter what I round down. So if it was 3.2 in here and I wanted to get rid of these brackets and just go to like normal brackets, okay, 3.2 would turn into 3. The brackets disappeared. 3.9 turns into 3. 4 stays as 4, and negative 3 stays as negative 3. But because it's always being rounded down, negative 3.1 goes down to negative 4, right? That's a lower value. So this is just in terms of execution of the brackets, and here's examples of how it like kind of would be worked out, right? If I was getting to a situation like this right here where I had an A, I had values for B, X, and H and had a number inside here, what would I do? I would have to change those brackets first before I do anything else. I can't go 2 times 2.4, right? Because that's not what this is. Those bars are kind of in my way. So I execute them, round down, now I can multiply and then add. Pi is just 3.14159. The negative is on the outside, it's not on the inside, so that just rounds down to 3. Negative 3 minus 2 gives me negative 5. And oddly enough, 0.33333 repeating. Any decimal at all, what's it going to round down to? It's going to round down to 0. Right? It's going to round down to 0.
Unless it's a negative decimal.
Yeah, and then it would go down to negative 1. Yeah, so it's always going to be in this picture right here. So
Awesome.
try plugging these guys in here and just do a few of these on your own and solve for them. See what happens, okay? So that page you're going to try on your own. Giddy up.